Welcome to Medical Myths, Legends, and Fairy Tales. I'm your host, Dr. Alan Christensen. Look, you know that between the latest online fads and the crazy media headlines, it's easier than ever to get confused about your health. And you and I just want to feel better and live longer. We want to know what works. And we can't wait for further studies. We need to make decisions today based on the best evidence we've got. Well, that's exactly what this show is here for. So let's get to it.
Hi there, this is Dr. Linda Kashaba from Integrative Health. Would you like some help with your thyroid? We would absolutely love to help you out. And guess what? We can even do remote care. Please call us today at 480-657-0003 to set up your first appointment. If you mention code podcast20, you will get 20% off from your first visit. That phone number again is 480-657-0003, and the code is podcast20. Can't wait to meet you.
Hey, Dr. C here with you, and welcome back to another episode of Medical Myths, Legends, and Fairy Tales. So super critical topic. This was about protein. Does animal protein and protein in general, do they cause cancer? Are they dangerous? And this is super critical because there are many popular views saying that protein should be reduced for various health purposes, that we should eliminate it entirely, we should eat less of it. We see this now from keto, from some in the paleo world, and some in the more extreme in the plant-based world. Others in all of these groups are less restrictive of it, but some are arguing that protein itself is a thing that is dangerous. And the pitfall is that there's a lot of evidence suggesting that protein can be of benefit in other ways, such as the loss of muscle through aging, body composition, recovery from exercise, these sorts of things. So how much is too much? Is it really bad? What is the best human evidence? And I'm really excited to talk to Dr. Gabrielle Lyon with this discussion. So she's a Washington University fellowship trained physician, and she's trained in nutritional science and geriatrics. So that's a study of aging and how we age. And this is an important part about the relevance of protein metabolism. She also studied with Dr. Dr Lyon, who's considered one of the leading protein researchers worldwide. So we had a good discussion about the topic and pulled out some practical takeaways for you. And she was surprised by the discussion about clean meat that we had. And we shared a lot of common threads amongst some of our early experimentation with macrobiotics and how it affected us negatively. So yeah, please enjoy the discussion with Dr. Lyon. Gabrielle, how you doing today?
I'm doing great. It's really nice to be here, Dr. C. We've talked about this topic quite often.
We have, and this is a big deal. You know, my second stage of becoming a health nut, I got very restrictive and had a lot of things go badly. You know, my appetite got out of control. I actually had some eating disorder behaviors for a while, and it sucked. And for me, the thread was when I was too low on protein. It was a big part of it. So I've realized that this is important. So there are many that claim that protein has some inherent dangers to it, and the less that we eat, the better. And the dangers that are talked about are, especially about cancer. I want to focus on that. I think you had some notes also about chronic disease, longevity, and I wanted to cover all these discussions. And, you know, there's a lot of like mechanistic arguments for why this or that could happen, but we've also got some nice data on what actually has happened to people, not just what we think would happen to people. So let's dive in.
I'm so excited to talk about this. This is my most favorite topic, is protein. You know, I trained under one of the world leading experts in protein metabolism, Dr. Dr Lyon. So I've spent decades with him, learning from him. And I love this conversation about protein and cancer. And do you know what's so interesting? Nobody ever defines what kind of cancer, one, are we discussing? And two, how is it even related? So we know that the major cancer killers, or the major cancers, I don't even want to say killers because people do survive breast cancer, but you're looking at breast, ovarian, colon, prostate. And then over in the other section is lung cancer, in which in the last 20 years, we haven't gotten any better at curing. And the rates haven't actually changed.
They haven't even, smoking changes hasn't affected that, or maybe smoking intake hasn't changed, smoking status hasn't changed much. I haven't followed that really at all.
It remains the death, I should say the death rates remain the same.
Got it.
So the amount of individuals who are actually dying from lung cancer is, I mean, that's probably when we look at the number one cancer issue is lung cancer. We haven't been able to improve survivability. And that actually has nothing to do with dietary factors.
Hmm.
And I think that's really thought-provoking when you take a step back and you look at the conversation. And the conversation now within the health sphere is protein and cancer. And there's been this huge push into veganism and vegetarianism, which actually, when you look globally, is 0.5% of individuals. So it's a much smaller amount.
0.5% globally. Wow.
It's actually not nearly as robust as the conversation bias, as one would say, is out there. It's almost like the mouse with the microphone, and these kind of propaganda-driven discussions, whether it's from big pharma or PETA, really color the conversation and confuse the individual. So when the conversation turns to protein and cancer, we really have to take a perspective that is evidence-based and really break down the discussion as opposed to it being fear-based. Number one, what kind of cancers are we talking about? And number two, what is the real relationship between food intake and cancer?
Food goes in patterns, and people often have bacon and eggs together, or they have whatever. There's often groupings and clusters, or they had their protein was in the context of things that were highly refined and processed, and cured and smoked or whatnot. So there's these contexts that become relevant.
Of course, and that's a really great point. Context is absolutely relevant. When the studies started coming out where cancer, and I don't even think that there are many, cancer is promoted by meat intake. When you actually looked at the data, it was not actually the meat intake, it was the processing of the meat and the heterocyclic amines and the carcinogenic ways in which meat was charred or processed with nitrates that ended up being the issue.
And it's a funny thing. It's easy to define diets in terms of an absence. Like we focus on the things that we cut out, the things that we exclude, and protein has been targeted by many fronts that way. Keto groups also are avoiding it and reducing it now, and many in the paleo world are talking about it being something also to limit.
And it's really an erroneous kind of thought process, because the issue isn't protein. So if we look at what drives cancer, and this is truly the hot topic, is this concept of IGF-1 and mTOR, right? And mTOR is this protein kinase complex that is a growth regulator. And it's actually in every cell in the body. So you have mTOR signaling, which is mechanistic target of rapamycin, if anyone cares, is in the pancreas. There's mTOR in brain and heart and skeletal muscle. It's in all different tissues. And the thought process is they've isolated the studies, right? And when you look at actually the funding of the studies and the researchers of the studies, they tend to be anti-animal. So they're not neutral. And what the components of it were that mTOR is related to cancer. mTOR stimulates cancer. And the biggest stimulator of mTOR, which is what people discuss, is protein, because of the branched chain amino acids. So there's a certain threshold, just to simplify for everyone, there's a certain threshold of amino acids that you taken into the diet, and it stimulates this process of mTOR. What people don't understand, and what's not really discussed, is a much more aggressive stimulator of mTOR is actually excess calories, and more importantly, excess insulin. And when you look at when you look at the Cancer Association, the cancer societies that are putting out information to the public and putting out information to other physicians, there's a very clear link between obesity and cancer. It is on, and I don't know if I can't remember if it's the American Cancer Association, but these non-biased groups that really their goal is to prevent suffering for masses, is we know that the primary risk factor that we can control aside from smoking and environmental things, is obesity.
Mm-hmm.
And it's really the obesity and the excess calories and the excess insulin that ends up driving this concept of cancer through mTOR, not protein. And that's a really important distinction, and that is not discussed at all.
And the pitfall is that, food intake itself, any type that's past some threshold, can all be falsely implicated.
Absolutely. And the studies, so if you look at some of the studies out of UCSD, where there was a really big study that actually got retracted, the data got retracted, and it was in Cell. And it showed that protein intake was linked to cancer. And again, they had to retract the data from the study and really issue corrections. They targeted that the protein groups were causing cancer. But actually, the bigger driver, mTOR, and they didn't actually look at carbohydrates versus protein. These were obese rats. So it was ad libitum fed obese rats.
So they could have as much as they wanted.
Which is not the normal population. So the basic foundation of the study was incorrect. And it created tons of headlines. And there was actually a statement issued from the top leading scientists in the world that sent a letter to the editor of Cell. Unfortunately, one of the researchers on this paper was and is a editor of Cell magazine. So they never published it. But it was a letter that was signed by all these world leading experts in protein metabolism that said this data is completely false and it's demonizing protein to an already sensitive population. And they had to retract some of the data and retract the statement. So it's really interesting when you look at the colors of conversation regarding this.
And you mentioned this before we were on that there've been trends of protein intake that have actually been going down over the recent past. Can you elaborate on that? Or?
Yeah, absolutely. We hear a lot that Americans eat too much protein and the world is consuming protein. But if you actually look at the NHANES data, and the NHANES data is it's the best data that we have, where it kind of collectively looks at dietary trends and intakes. And the average female consumes around 60 grams of protein a day, which is, if you're consuming the RDA, that is absolutely the bare minimum that one should consume for functioning. And that number is 0.8 grams per kilogram body weight. It is the studies, they are really working hard to implement improvements in that, because we know that anything really at the RDA and certainly below is not optimal for body composition, for blood sugar, or for health. The average male, according to the NHANES data, again, that very large data set, is around 90 grams. And we know that as an individual ages, they need between 30 and 50 grams of protein per meal. So you can only imagine that if you're talking about optimization, that is so much lower than any individual needs to be consuming. That, if you look at aging, and I did my fellowship in geriatrics, if you look at aging, one of the biggest risk factors for all-cause mortality is low muscle mass. And one of the biggest dangers in aging is falls. And why do individuals fall? Is because they don't have enough strength and muscle mass to sustain normal life. We require protein for muscle mass, for sustainability of our tissue. So you can see how detrimental this concept of we're eating too much protein is to longevity.
And like you mentioned, our needs, if anything, only go up as we age.
That's 100% true. And in fact, we know that the PRODAGE study, which any of your listeners can pull up, requires a minimum of 1.2 grams per kilogram body weight.
So way above the minimal RDA threshold.
we know that the data would support almost double. In fact, all the metabolic studies that you look at are easily 1.8 grams per kilogram per pound body weight. And we can include some of those links. American Journal of Nutrition showed that increasing dietary protein from 1.2 to 1.6 was an absolute successful strategy for the prevention of obesity. And when you talk about cancer, you're looking at obesity.
So talk to us a bit about why that change in protein could affect body composition and obesity.
That's an interesting concept. And I think one of the reasons that we're seeing is that, number one, as you age, you require a certain amount of protein for the protection of muscle. So we know that, again, we talked about 30 to 50 grams for stimulation of mTOR, which is actually a good thing, not a negative thing. The other thing is that increasing your intake of protein increases fatty acid oxidation. It improves hypertension profiles, and this is through arginine, one of the amino acids. It also replaces carbohydrate intake. In fact, we don't even know the upper limit of protein that would become detrimental. But we do know that as it relates to cancer, that the insulin stimulus of a protein meal is very minor. It's a phase 1 insulin response, very small amount to help promote muscle gain, anabolism, as opposed to a constant as a phase 1, phase 2 response, a very robust response from carbohydrates. So really, when we look at cancer, it is absolutely not a protein issue. It is an excess calorie, excess insulin issue, not protein. And in fact, when you look at one of the killers of protein is cachexia. And cachexia is that wasting syndrome. 22% of all individuals with cancer will actually die from cachexia. I mean, this is really important stuff, and I really applaud you for being so forward thinking and bringing individuals on to talk about it, because the misconceptions and the biases of the conversation really impact individuals' health. And one of the initial things that you had said, that you were having eating disorder-like behavior when your protein was low, that's actually a hypothesis called the protein leverage hypothesis. Mm-hmm. I don't know if you've read, I think it's Simpson.
I have, but please explain that for our listeners.
And this is fascinating. And I think your audience can really relate to this idea of, and I've experienced it myself as well, and with the patients that I've seen, is the protein leverage hypothesis is that individuals will continue to eat high carbohydrates or continue to go on food hunts until their protein is adequate.
And if you're talking about low protein foods, you won't get there. You'll keep on eating and eating and eating and almost never get there.
That's absolutely true. And that's what we see. So as individuals go on the low fat diet or a lower protein diet, that is absolutely what we see. And it affects their neurotransmitters and it affects their drive to feed. And it becomes a tremendous challenge for individuals, especially if we're looking at this protein and cancer concept. Again, it's not a protein and cancer. It's a protein and excess calories issue.
Yeah. And I've seen studies showing that people who are given just free feeding diets at varying levels of protein, they eat completely different amounts of food. I think many that have gone low carb and find they do better, I think by and large, once you factor out the protein portion of that, there seems to be less of a benefit of the low carb portion. In many cases, they're cutting out processed carbs, but then adding in more high quality proteins. And they usually by default end up being on a higher protein diet, and you fill up faster from that on a lower food intake.
Absolutely. And we know it affects brain neurotransmitters. And this is work done by Heather Leidy, and I think she's out of Nebraska. somewhere somewhere in the Midwest, and she actually imaged women's brains, adolescents' brains, and she looked at those individuals that had a high carbohydrate breakfast versus high protein, and she looked at the dopamine reward pathways, and she looked at a functional MRI. And fascinating, her findings were that those individuals that she could almost predict, that the data could almost predict who was going to end up eating poorly later on in the day. And it was really based on the carbohydrate versus the protein intake.
We'll be right back after a word from Integrative Health.
We hope you are enjoying this episode of Medical Myths, Legends, and Fairy Tale. This is Dr. Roz at Integrative Healthcare. You know, so often we hear from our patients that their primary care physician has told them that their thyroid and hormone levels are fine and they should not worry. Yet the patients still have symptoms of severe fatigue, thinning hair, and weight issues. Unfortunately, this is too common with thyroid care. The good news is we can help and there is hope. The doctors at Integrative Healthcare, including myself, specialize in naturally treated thyroid, hormones, and adrenal issues. We would love to get you started on the path to ideal health. From the comfort of your own home, we can get treatment from one of the doctors at Integrative Health via telemedicine. Go to integrativehealthcare.com to become a new patient today. Use code PODCAST20 for 20% off of your new patient visit. Again, this is integrativehealthcare.com. Use code PODCAST20. Get back on the road to thriving.
And now, back for more medical myths, legends, and fairy tales. So in terms of the risk and the fear, there's many that talk about the China study, for example, as one case study about protein being carcinogenic. Is that something that top of mind you're able to discuss or mention? Or?
Certainly. So we know that the China study is really not study, and it was selected data from different areas. And actually in the science world, that is not even considered a study or relevant when it comes to looking at data. It's, again, it's almost, the China study is similar to the blue zone, where they looked at, certain areas, one area is it's not populated and people are really active and there's no pollution. Like with the China study is compared one area that was really populated with tons of processed food, no activity, smoking, and just a really bad lifestyle, compared it with a different area that, people were active and eating fresh food and no pollution. I mean, it's so ridiculous when you look at that and somehow you relate it to protein when really there was 900 other factors.
I took a close look, and one of the more robust variables they argued about protein intake was stomach cancer. And I took a little deeper look at some of the raw data, and apparently some regions, it seemed that their pork intake did correlate with stomach cancer. But then there was also data about the habits and the cooking methods. And apparently in many regions, it was undercooked, and there were higher rates of parasites because of that. And the parasitic infections were known to be drivers for stomach cancer.
And that's really important. I mean, there you have it. I mean, that's fascinating. And it's really interesting, the conversation that it goes to somehow it's protein, which is so odd. And I think part of that is this emotional drive, because the fact that protein has a face. So it's kind of the black sheep of the macronutrient family. But if you look at the data and you look at the risk ratios, and we know that risk ratio is kind of if you do this, then your risk of having it is this. So for example, cancer and smoking, the risk ratio of cancer and smoking is 12. And in order for a risk ratio to be relevant, it has to be above 2. They have looked at the risk ratio of protein and cancer. And Dr. C, do you know what it is?
Well, depending on type of cancer. So the highest number I've seen has been like red meat and colorectal. And that'll be like 1.01 or 1.02, if I remember correctly.
Exactly. And so essentially it's irrelevant. They're not related, because in order for it to be clinically significant, it should be above 2.
And I've heard some numbers that if you have 10,000 people per year that you're tracking, out of them, if they're adults, both genders, ages mid 30s to mid 60s, you'll see about 63 people develop colorectal cancer. And so that 1.01, 1.02 relative risk ratio would mean that that rate of 63 per 10,000, 62, 63 per 10,000 might end up being 65 per 10,000. So if it is there, it's something that you would see in a large group, but yeah, it's not like smoking.
The potential benefits. So what are the other options? If you're not going to eat protein, you may eat fat, or you may eat more likely carbohydrates. So then the question becomes, what are you feeding on? And that's a really important question because, I suppose a ketogenic diet, and I don't necessarily prescribe that for my patients because I think that muscle is the largest organ in the body. In fact, I know it is, and I know that it is the organ of longevity and how important it is for aging. The question is, if you decide to underconsume protein, and we know, like we talked about, that anything even at the RDA is inadequate. And when you look at where the RDA came from, you're looking at nitrogen balance studies from 1940, which were essentially extrapolated pig data. No one ever goes to the doctor and says, okay, well, tell me about my nitrogen balance, right? So in essence, it's a very ineffective way of measuring protein necessity and also protein benefit, right? So it's, and it's definitely been discussed that it's no longer viable, but the recommendations have not yet caught up.
So what about those who are health conscious, they're being deliberate, they are vegan, they are plant-based, perhaps for ethical, environmental reasons. So if someone is deliberate, it's a shorter list of foods to pick from, but they can still hit those targets, right?
They can. And one of the ways to do this, and we've discussed this before, I think personally, because I always like to snoop on what you're eating. And, one of the ways that if you're vegan or largely vegetarian is that you'll want to increase your branched chain amino acids. So make that lower quality protein higher quality. That's really essential. And you can do that through a scoop of any high quality branched chain.
And those are not animal derived. Those fit within the guidelines that someone would have.
Yeah, it's really essential. If there was an argument that held up that protein, I know that you had mentioned TMAO, which is this chemical byproduct, or Dr. C, maybe you have a smart way of explaining it, but it's really high in fish.
Yeah.
And it's not been,
yeah. Well, it's a compound that we form in our flora, and we find it innately in some foods, and we generate it in our gut. And there's been just data linking it at high levels to cardiovascular disease. And it's a funny thing, but it's also, it's measurable in the blood as well. And I just had my full physical about 2-3 weeks ago. My protein intake is pretty high as far as just overall. I probably average of complete proteins, 160, 180 or so grams per day. My TMAO levels were extremely low, like on the lowest end of the scale. So it was the relationship between it and dietary protein is not just a one-to-one type thing. Right. It's much more indirect. There's also many genetic factors that play into it. Yeah,
absolutely. And that's interesting. And how much do you weigh?
low 160s is typical. 162, 164.
So I think, from my professional opinion, you're absolutely doing your protein intake 100% correct. And I think that as we move towards around 1 gram per pound body weight, and especially you're really trim and fit, at the lower end, especially based on activity. Individuals of studies can go up to 2.5 to 3 grams per kilogram per day. We've never really been able to identify what that upper limit is. It's possible that the upper limit may be due to issues handling urea, things of that nature, but we haven't seen it.
Well, and it's not so much the case that there's a misnomer that we can't assimilate a lot at once, right? But we do need it frequently too. So it's not the kind of thing you can just do in a big pile and call it good for the day, right?
Absolutely. So that's actually a very important point, and it goes back to that mTOR signaling, which is necessary for growth, is that we eat protein in discrete meals. And one of the ways in which you can keep blood sugar stable and really optimize your body composition for longevity, right? So we know a huge risk in aging is sarcopenia. We know that obesity not only is a risk factor in cancer, but also Alzheimer's. So the wider the waistline, the lower the brain volume. Essentially, one aspect of Alzheimer's is type 3 diabetes of the brain. So having a lower protein intake is incredibly detrimental. But not only that, also dosing it incorrectly. And that's why, when you're having, so for you, 160 grams of protein or 180 grams of protein, you really need to divide that into a discrete meal of, say, 40 to 50 grams. You'll optimize muscle protein synthesis and give yourself 4 or 5 hours for the body to reset, what we believe to be that mTOR signaling and that anabolic process. And then you stimulate it again, as opposed to stimulating snacking on carbohydrates throughout the day, where you're constantly driving that very expensive metabolic process. You are very targeted in how you do it. So you have protein in discrete meals. By doing this, you minimize insulin. You also get the best utilization of the protein, and you optimize the amount that you're eating for overall longevity. It's not about who makes it to 95. It's who makes it to 95 well.
So health span and lifespan. Yeah.
Yeah.
Yeah, and that's worth making a distinction and talking a bit too about some of the work talking about the fasting and the fast mimicking diet. So health span is defined as, just like you're saying, making it to whatever age well. And then lifespan is about the idea of, could we go past whatever the human genetic potential is? If that's 120, is there a way we could exceed that? So we've got a lot of good human data saying that if we do these things, we can really achieve a good health span. And then there's data which is, I would argue more mechanistic, more hypothetical, that other things could change lifespan. And yet those are the things that would be the detriments towards health span.
Right. It's really interesting and silly, when we take a step back and kind of tune out the massive influx of information that maybe come from not sources that are vetted, and you really think, what makes an individual strong? What makes the quality of their life long? And it's the ability to live independently, which requires thinking independently and moving and being able to be mobile independently. And all of those relate to a strong physical structure. So if an individual were to fall, let's say, or they were, God forbid, to get cancer, the ways in which you protect yourself are to have through, midlife to later life, to be the strongest version of yourself. And this then trickles into metabolism. So how are you most efficient at utilizing your calories, your resting metabolic rate, which is all based on the quality of your muscle.
Yeah. So what about the popular low protein 5-day modified fast programs that are out right now?
It's interesting because, again, being a geriatrician, I can tell you, and this is, there's some really good data from Doug Patton-Jones. And I would really encourage any individual who's interested in kind of nerding out and learning more from some of the world leading experts to look at Doug Patton-Jones's work. And he talks about the trajectory of aging and bed rest. So, for example, a fasting mimicking diet goes through a period of incredibly low protein. None. It's actually a methionine restriction. Mm-hmm. And methionine restriction is interesting in and of itself in the way that it's mostly done in mice. And because mice have fur, the methionine need is actually different. So we don't necessarily know how that translates to humans. So back to the methionine restriction or protein restriction. We know that as individuals age, it becomes very difficult to recover from muscle loss. So any age over 35, 40, 50, depends on your baseline metabolism and inflammation. As you go through periods where you decrease your protein intake, because we know that there's really two ways to stimulate and protect muscle, and that is, number one, training, primarily resistance training, and number two, dietary protein. Most individuals are not really doing heavy and consistent resistance exercise. And then you remove the stimulus of mTOR and the amino acids from protein, and you destroy that tissue. And rather than it be a slow decline, it is very difficult when you go on a 5-day fast of protein, because you're probably not really training. Once you lose that tissue, it becomes very difficult to build that up.
And just for the listeners, a quick way you can know if that's happening or not is just to compare scale weight loss versus waist inches lost. A lot of programs like that, someone could see dramatic pounds lost, but no significant inches lost. And in that case, the pounds are coming from muscle mass.
And that is really detrimental in terms of resting metabolic rate, in terms of ability. Everyone talks about cholesterol, and one of the largest site for fatty acid metabolism is the muscle tissue. So it just becomes incredibly detrimental. When you're young, you have a lot more flexibility. And if you want to do this kind of fasting mimicking diet when you're young and you're training, you definitely have more capacity for metabolic flexibility. Do I think that there's some value probably in fasting? We do know that it increases autophagy. There are components where, some data suggest that it lowers inflammatory markers. Probably all is great. But I would argue, if you're going to do that, why not do a modified protein sparing fast, which is something that has been used, for decades, in which protect your lean muscle, still go on a very low calorie diet, whether it's 500 or 800, obviously under the supervision of a physician, and protect the tissue that is your metabolic currency. That would make the most sense to me, because there's no scientific basis. I don't know. And Dr. C, maybe you can, chime in here what the evidence would be. I mean, just show me some of the evidence where decreasing your muscle tissue is valuable. Decreasing protein intake below the RDA is valuable, when 30 years of research shows that's not actually true.
Well, and that's the thing, is that it's how do you define evidence? And many people define it as just really theories or ideas. And I heard someone say that you have to find the data as it stands and then kind of connect the dots, because not all the data that we like. And the lack of information is why we need more data, but a lack of data doesn't mean that we can skip the line. It doesn't mean that we can just then make assumptions. And you can connect the dots for sure, but you can connect the dots in a lot of ways. The dots aren't numbered. And based on how you connect them, you can get different pictures. So it becomes almost like a Rorschach of just extrapolating your own beliefs and biases when you start relying heavily upon animal data or test tube data.
And that's a real challenge, because we have randomized controlled trials about higher amounts of protein. I mean, JAMA in 2018, and that we can have links for your listeners, showed that higher amounts of protein at 1.3 grams per kilogram a day for 6 months was much more beneficial. There's other data that shows higher protein intake preserves lean muscle mass and increases satiety in obese women. And we're talking about high protein groups at 1.4 grams per kilogram or above. I mean, this is where we know this is human data that is good, solid data. And that's the part that gets confusing when individuals are making recommendations that we absolutely know are detrimental for individuals' health.
Well, and like you said, the case about having muscle mass throughout aging, that's pretty much a done deal. There's like really no disputing that you're healthier to have that, and that as you lose that, we see all the risks emerge, even things like pneumonia that you wouldn't see the connection directly, but that data is so strong. And the main things that preserve that, we've got our dietary protein status. It's all comes down to like anabolic signaling, how much of a signal we have to preserve our muscle mass. And so there's our androgenic hormone load, testosterone or DHEA or growth hormone. Then we've got whatever type of training that we're doing, depth of our sleep. We've got our protein intake. And these are all things that become harder with age. So you mentioned about aging, but just to expand upon a small point you touched upon, this is tougher for the female population as well. Women have one of those parts of that, the androgenic signaling. They have even more of a loss of that than men do with age. They're already at a lower point, and it's even more of a dramatic difference. So they're even more vulnerable to this loss of muscle mass.
Absolutely. And then with the change in estrogen and the hormones, like you're saying, and another interesting point that we didn't really touch upon is this concept of insulin-like growth factor. And people say, well, protein increases IGF-1.
Yeah.
And if you look at IGF-1, it's actually not oncogenic. So it doesn't, cancer is a disease of the genome. IGF-1 is a growth promoter, and growth isn't necessarily bad. There's an issue if you have a genomic disturbance like cancer, then having elevated levels of IGF-1 would be detrimental. But if IGF-1 caused cancer, then every 30-year-old in the world or 20-year-old in the world when IGF-1 is the highest would have cancer.
I've heard the analogy about like water for plants. Water alone won't make plants grow. You can't just like pour water on plants and have them grow faster. But in the absence of water, plants will shrivel. So something like that. And the other factor with that too is just the fact that other variables affect it. And the data that I've seen, I'm sure you know about this better than I do, but the data I've seen specifically about IGF-1 is that the extent to which it is relevant is the extent to which it's way outside of the typical ranges. So someone who's well above the 350, 400 range spontaneously, then
Absolutely.
Yeah, but really not the garden variety levels people tend to be within, and not the levels to which, and when someone is that high, that's not their protein intake. That's some unusual genetic variation.
That's right. That's absolutely right. So again, it's just more confusion when it comes to what is actually true, and taking a step back that it's, the concept of IGF-1 and protein causes cancer is completely ridiculous just based on the concept of what IGF does. IGF isn't, a initiator. It in of itself is a promoter of growth. So it's just very interesting.
So this is totally tangential, but not really. Have you followed I don't know if we've talked about this before, but have you followed the clean meat movement?
No, maybe. You'll have to tell me more.
That's the term the industry is trying to revolve around. And people think about clean meat. Some think about like grass fed or whatever, but no, this is laboratory grown. So
that's terrible.
So tell me
I just
why.
mentioned something about the sustainability, and only if it's okay.
Yeah.
So, it's really interesting when you look at sustainability. Let's just talk about the US. People talk about how protein is bad for the environment. Actually, if you look at the data, and right, so this is the EPA is coming out with these numbers, cattle and dairy in totality contribute around 3.6% of all greenhouse gas.
I would have guessed a higher number. Yeah.
Yeah, that's nothing. So let's say everybody does meat. So let's say you killed all the cows and got rid of all dairy. You would essentially reduce greenhouse gas by maximum 3.6%. Max.
Well, let's say that you did a biopsy. You're a doctor. You know what this means. But to the public, you do a shot. You do an injection, basically. You do a biopsy on one cow's leg one time, and you pull some cells from that. And from there, you could have basically an unlimited supply of actual protein, actual meat, just as it would be from that cow, with no other cows being involved ever again. And you could completely select any nutritional changes you want if you wanted to make it like fish as far as the fatty acid composition. So the basic idea is you're taking a cell and you're feeding it in a culture. So kind of like hydroponically growing plants. And whatever that culture is whatever the nutritional profile ends up. So you can have, more zinc, you could have more omega-3 fats, you could change whatever you wanted to change. You could make it to where the flavor varietals are distinct. And the amount of square footage required, the amount of water required. Overall, I'm not vegetarian. I'm sympathetic to some of the arguments, but there's also thoughts about just the fact that we have foodborne infection and foodborne illness, and and perhaps the greenhouse effects are less than many think. I don't know those data. I don't argue with you on that. But how cool would it be if we could just have the food we needed in a more efficient process and without there needing to be animals needed?
It would be incredibly interesting.
And the funny thing is that I've heard people talk about this and be kind of squeamish about it, like, "Oh, that's weird, that's gross," and the funny thing is too is that I really haven't heard much interest amongst vegetarians or vegans, But
oh, that's interesting. That's interesting.
They seem pretty indifferent. They're not really feeling like they need animal products of any type. But the idea of the concerns that we have about it, it's sterile. I mean, one thing too, animal protein, you've got to wash your countertop. You got to manage things in the kitchen. Well, if it were clean meat, it's sterile. It wouldn't go bad. It wouldn't have problems that way. And honestly, there could be a point within the next couple of years to where these things are cost effective, available for the consumer. There's some versions that are out right now. Ground meat is one of the easier things to make. A steak would be difficult because that's also a fair amount of fibrous structures and vascularity and many more three-dimensional structures besides just the actual protein component. So that's a whole nother level of technology that we don't have access to. But ground meat, we have access to that. Egg white, milk, fish, poultry, those are completely doable. It's just a matter of scaling right now. So yeah, these things are happening. There's a place called Memphis Meats, and when they are up to speed, their goal is to have a pet pig walking all around the barbecue restaurant.
Oh my God. It's almost science fiction-ish. This reminds me of, remember they used to have Star Trek where you could, in the show where they
replicators
pick a food and it just like appeared.
So check this out. So people have talked about the idea. So 3D printing. So you take the idea of 3D printing and then you take the idea of this process, which is just cells in aquaculture. So you could theoretically receive something in the mail that's kind of like a tea bag, and you could drop this in a device that could be about the size of a printer. And in another 6 hours or so, you could have the world's premium, best quality ahi tuna belly there for dinner.
It's just
that's plausible stuff.
I have to say it's weird.
There was the issue about whale oil, and whale oil was protested for quite a while by people thinking that we were just wiping out these complex species. And the concerns went on deaf ears. But once kerosene was made and patented and available, and it was cheaper, then it was all over. And there'll be a point. The first versions that hit the market will not be cost effective. And they've already made some that are, they're not scaled yet. But there will be a point at where the average consumer has already tasted it. They know that it tastes as good or better, and it's cheaper. And I think at that point, it's going to be a done deal.
Wow.
And right now, all the big animal growers are already investing in this. They're already behind this because they know the writing's on the wall.
How is that possible? Individuals are concerned about GMO and all of these other things that, are probably not really relevant, but they're open to eating.
To be honest, this is my biggest fear, because I honestly think that this could be a very positive technology in terms of just, cutting our demand upon fossil fuels for transporting, and cutting our demands upon water resources. Yeah. Of course, this is where all antibiotics go. This is where drug resistance comes from. So if we can end that part of it, and we can end foodborne infection, those would all be cool things. But I do think that the biggest reason that it would not work soon would not be for logical reasons, but would be for people that have just irrational fears about it or unfounded fears about it.
So interesting. It's really interesting. It's going to be
phenomenal. phenomenal book called Clean Meat, and there's been some good TED Talks about it, but fascinating topic.
Yeah, I'm going to check that out. I'm really, that's just really interesting.
And, and a tricky thing about it too, we've talked a lot about the protein and plant-based versions, and again, you totally can do that. The reason why it is trickier is because it's not just about do you get the grams, but do you get the grams relative to your total food intake? And like you mentioned before about the protein, I'm gapping on the name of the concept again, but the
protein leverage hypothesis.
Yeah, thank you so much. The idea is that you can get enough on foods that are not inherently dense in protein, but you need so much food to do that.
Right.
And that's the pitfalls. You're still at a high food load and still a high insulin demand.
Right. I mean, it takes between 4 and 6 cups of quinoa to get the same amino acid profile as a chicken breast. It's a 3-ounce chicken breast. And I was macrobiotic for a really long time, and I got...
Were you really?
I was.
I did that too.
I was vegetarian for a really long time and was macrobiotic, and I ended up getting really sick, and I, was over consuming these high carbohydrates, metabolically unfavorable foods to try to, obviously, I was really athletic. It's kind of been my way of life always. And I had a really hard time keeping up with the protein needs. And I got really sick.
So when you were macrobiotic, what kind of training were you doing?
I was training at altitude.
Was that strength?
I was training at altitude, and I was putting in a lot of mileage running actually, and lifting and training at altitude.
Wow.
Because I've done Fitness Americas and kind of competitive dance, gymnastics track, and the energetic demands on my body, and I naturally have a quicker metabolism. I got really sick, and I couldn't, it was really hard for me to transition from macrobiotic to actually eating, animal-based product, which was, I remember it very clearly, but I couldn't support myself. And at some point, the health aspect of it, and also just like you, I was having a lot of disordered eating, and I was just eating and feeding, and it's not a good situation.
And some days there's just not enough pressure cooked rice in the world to...
For sure, especially in the college dorm. That's right. Right. So the individuals that want to remain vegan or vegetarian, as you age, it becomes much more challenging because solely the amount of food that you have to ingest is so exponentially higher to support your growth and then your longevity.
And those who are, I would argue that soy, a lot of the concerns about soy, I haven't found strong basis for them. I would rather someone consume that as complete protein than to avoid it. We've got more vegetable protein options. There's some mycoproteins that are coming on the market, being looked at. There's some complete potato protein extracts coming out soon. So more things coming up in the near future.
That's interesting.
So the soy, any different comments about soy or?
No, I think that you're right. I think a lot of stuff that we're discussing, there's genetic variability. I mean, I have a really good friend who is an orthopedic surgeon, and she is keto vegan, and she does fantastic. And it's really amazing to see, I think that probably 0.2% of the population can do really well like that. And I don't think we know genetically why that happens. Just like with the TMAO, some individuals can tolerate it versus other individuals, it becomes toxic. With the soy, I think that there's probably some genetic component to the byproducts in which an individual would break that down. But I would certainly rather have them, the real information, I don't think that the data supports that we shouldn't be eating soy, but I think it's probably somewhere in the middle, depending on the individual.
And the tough thing too, like you mentioned about the friend who's on a pretty extreme diet, one tough thing is that we can certainly gauge how we do in the short term, but when it comes to things like our health span and our lifespan, we get one shot at this. And that's why I love the work that you do and others when we focus on larger outcome studies, just to try to predict that. And because we can't just like reboot and try again. So we've got to try to figure out what do we think is going to work based on what has worked for other people.
Yeah, I think that's totally true.
So cool stuff. Any closing points about protein cancer that you would hope to address that didn't come up or I neglected to ask about? Or
I think that we covered a lot. I think that discussing some of the real important differentiation between this concept of mTOR, which is only going to get more heat, really taking a look at that it's a natural process in the body and that mTOR is specifically sensitive to branch chains in muscle versus the mTOR in the pancreas, which may be sensitive to something else like insulin. That we really differentiate and take a much more objective look at the information that's being presented to us, I think is incredibly and deeply valuable for the longevity of our community and our families and ourselves, to not be easily persuaded by poor science or agenda-driven things. I think that's I can't articulate that enough. So,
and speaking of which, just to help the audience who would like to connect more and learn more from you. So you put out each week you do some synopsis of what you're seeing in the medical literature, and you put out some content that way for everyone. Is that correct?
Yes. So people can find me on my Instagram. I'm pretty active. And my website, Dr. Gabrielle Lyon. Most important is where I'm consistent with the content is I release a newsletter, and I always put in good studies that I'm reading. And actually, I've been trying to get Dr. C to do a journal club with me, even though
that'd be cool.
I'm working on it with you. Even if it isn't thyroid, I'm gonna persuade him, because it's really important that we learn from each other. And so I put out a newsletter, and it typically comes out every Sunday, although I'm a little slower these days being so pregnant. So it might come out Monday. Just be patient. And it has really good evidence-based articles. So for example, this one that's coming out is going to have something on the neuroendocrine reasons for amenorrhea, which is really interesting. So it's not hormonal, but we're talking about the top-down approach to amenorrhea. Also, how individuals who are or have been on testosterone therapy, ways in which you can effectively improve spermatogenesis through HCG therapy, just interesting stuff. And I always am reading and putting interesting stuff out there. And they can download a free Lyon protocol on my website, which is www.drgabriellelyon.com. And that will be actually being upgraded shortly. So they'll get a 2.0 version. And stay tuned. I'll be launching a monthly challenge.
Cool.
It'll be amazing. It'll be really interesting to witness individuals' transformation.
Well, I've been a fan of your work, and we're going to get all these links up, and this has been helpful stuff. So, Dr. Lyons, thank you so much for your time.
Yeah, thanks for having me, Dr. C.
Look forward to seeing you soon.
Bye.
Hey, Dr. Christensen here. Thanks so much for joining me for another episode. Is there a topic you'd like me to cover? I'd love to hear from you. Just go to Dr. Alan Christensen on Facebook or Instagram, write your question, and use the hashtag #MedicalMyths. Did you find this show helpful? If so, please take a minute and leave us a rating on iTunes so that others can know. Thanks much, and I'll be back with you real soon. Bye-bye.